Hi, everyone. We are beginning Unit 2, which is titled The Chemistry of Life. The first few lessons will be a brief overview, as you recall the chemistry that you learned in physical science. Here are your objectives for this lesson. As of today, 118 elements have been discovered, 92 of which occur naturally. Elements 119 and 120 are currently being sought out, and it is predicted that they will be discovered by 2022. As you will learn, ions play an important role in biology. You should recall that ions are charged particles. They have either gained or lost electrons. This is represented by the symbol with a negative or a positive being present. Recall that neutral atoms have the same number of protons as they do electrons, therefore they have a net charge of 0, making them neutral. Remember that chemical reactions occur by a rearrangement of electrons. The electrons in the valence shell, or the outer shell of each atom, are what's available to react. Recall that these reactions are driven by the desire to be happy. Each atom wants to have a filled valence level. Ionic bonds are formed when electrons are transferred between two atoms. This includes a metal and a nonmetal. One gains electrons, one loses electrons, therefore resulting in two ions, one positive, one negative. Those two ions are then attracted to each other, similar to a magnet. These are what forms compounds. Just like compound words or two magnets that are stuck together, they can be pulled apart and stand alone. The same is true about ionic bonds. With enough force, the electrostatic attraction between those ions can be separated. This cartoon represents how ionic bonds are formed. You see that the positives from the inside the classroom are attracted to the negatives outside the classroom. Remember, opposites attract. Covalent bonding is in essence a collaboration between two atoms. They are able to determine how they can arrange their electrons so that they can share them and both be happy. These are formed between two nonmetals. We refer to these as molecules. These are bonded for life. They are not able to break up from one another because then neither one would be happy. Multiple electrons can be shared between two atoms in a covalent bond. This is represented by the number of dashes in between the two atoms. A single line represents 2 electrons, a double line represents 4 electrons, and a triple line represents 6 electrons. A single, double, and a triple bond. When bonds form, the chemical world is creating a more organized system of matter. However, over time, all things tend to become unorganized. This is a concept known as entropy. As entropy increases, the randomness or disorder increases. All things will eventually die, wear out, or fall apart. This is the randomness or disorder I am referring to. Ice melts, humans age, flowers wilt, cars rust. I know some of you can probably relate to this picture. Your room might have started out clean, But as entropy increases, the randomness has also increased. Enough with our physical science review. The elements that make up all living things include what we refer to as SHNOPS. You will need to know this. It includes carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Carbon atoms play a fundamental role in the compounds found in living things. Carbon atoms are the building blocks of all molecules essential to life. Please get that. They are the building blocks. Carbon-based molecules present in living things are called organic molecules. Completely different from organic food that you buy at the grocery store. When you look at the structure of a carbon atom, you see that it has 4 valence electrons, meaning that it needs 4 more electrons to be happy. This is why carbon is present in so many molecules. It has the ability to bond to up to 4 different atoms. Carbon easily forms covalent bonds with hydrogen and oxygen. So all organic compounds are composed mainly of these 3 elements, C, H, and O. This picture shows the versatility of carbon. You see that it can form many different shapes, such as straight chains, branch chains, and even rings. These are 5 examples of carbon molecules. However, we will not be studying these specifically in class. These are not molecules that make up living beings. However, they are formed from living things. The most important takeaway from this lesson today is that carbon is the building block of every molecule essential to life. The organic molecules we will be studying are grouped into 4 categories. These are extremely large molecules, so we refer to them as macromolecules. Carbohydrates are our body's main energy source. Fats serve different roles that we will discuss further. Proteins make up our hair, our nails, our muscles, and are even involved in the expression of our traits. And nucleic acids are the building blocks of our genetic material, our DNA. These 4 macromolecules will be the main focus of this unit.